In 6.1.4, we look at tangent and inverse tangent, and we apply the same structure to this as we did with sine and cosine. So we're going to look at inverse tangent right now. The arc whose tangent is, speaking of the inverse, or arctan. Now we remember that tangent is just equal to y over x, sine over cosine. It's going to help if we look at the unit circle here. And we'll build the unit circle. Now, I want to evaluate. We're going to find arctan of rad 2 over 2. Or actually, excuse me, not rad 2 over 2. Arctan of 1. Let's make it negative 1. Okay, so if we're thinking of arctan of negative 1, we need to figure out where on our unit circle are y and our x coordinate the same. And another way of thinking about it, what quadrants is arctan negative? Now, from all students take calculus, we know that arctan is negative in quadrants 2 and in quadrants 4. And it's actually going to be negative at 3 pi over 4 and 7 pi over 4. We draw on this line. We'll look at the coordinates at each point to evaluate it. Rad 2 over 2, negative rad 2 over 2. They're the same, that's why we get 1. And then since one of them is negative, that's how we get the negative 1. So we have 7 pi over 4. We also have 3 pi over 4. Now, we have an issue with this. The issue is there are two solutions, and we only need one. We need to restrict the range. So if we restrict the range, we end up only looking at this part. Our restricted range would be negative pi over 2, similar to sine, and pi over 2. So our domain here, negative infinity to positive infinity, and our restricted range is negative pi over 2 to pi over 2. Now if we wanted to look at this on the graph of inverse tan, if we wanted to graph it, what the graph would look like is, go ahead and sketch it in. Your graph's going to look something like this, and the nice thing about this is the asymptotes are right there at pi over 2 and negative pi over 2. So here's negative pi over 2, and here's pi over 2. And by looking at that, this passes the vertical line test. It only goes through one of them. I guess quick correction on the restricted range. Because it's approaching an asymptote, this won't be closed. It will be open, though that's kind of just a subtlety. Alright, so that's inverse tan. That's how we restrict the range on it, to only get one solution. So if we look at arctan, we know that arctan is equal to 3 pi over 4 and 7 pi over 4, but the calculator only gives you one solution. It only gives you 7 pi over 4, so this 3 pi over 4 won't work. It's not in the restricted range. The only solution that works, is this one down here within the range. The second part of this that I need to address now that connects kind of algebra to calculus, and you will need in order to do a couple of your homework problems, is called the angle of inclination. Angle of inclination. To kind of look at this, we're going to look at a line. We're going to go back to Algebra 1. Just a little bit more. So, here's your line. Now, the equation for a line is y equals mx plus b, slope and an intercept. But now we're going to connect this to trig. and tangent, which I know is going to sound strange. So if we drop a theta in here, and we drop an altitude and a right angle, we can go ahead and identify our different sides. So we have opposite, adjacent, and hypotenuse. Now, I'm going to tell you that m is the same thing as tangent of theta. Now right now, that might seem like a stretch, but if we're to look at tangent of theta is equal to SOHCAHTOA, opposite over adjacent. And if we look at our opposite and adjacent side, another way of expressing slope is change in y, rise, over change in x, which is equal to m. So here's the connection. If we go up to opposite and adjacent, if we look at this, our rise is our delta y, and our run is our delta x. So tangent of theta is actually equal to our rise over run, or equal to m. These two are exactly the same thing. Which is pretty powerful because it allows us to make calculations later that Algebra 1 might not have been able to do, because now we have theta of an angle. Alright, pretty cool. These are the notes on 614, and we'll continue to kind of build on these concepts.